Welcome back to the. Okay, let me relax. Welcome back. Wait, my mic is not here. Apologies for the soundscape. I apologize. It's popcorn. As you can see, in retrospect, every time I make one of these videos, I always look back. Or I always look in the beginning to see what it looks like, and it just looks like a mess. The room is not a mess, although my life is a mess. But the room is not a mess. This is just a storage room, basically. So there's a lot of stuff in here. But also that includes popcorn. So yeah, so it is what it is. It is day 108. There's some comments to run through. Thomas Wong says, "Good to see you grinding, brother." As always, you too, my man. So if you don't know, we're just basically the whole channel's goal. We're just chasing after Thomas. I'm gonna keep it 1,000. We're just chasing after him, and hopefully we can get there before it's too late. Before we don't have a chance to catch up. And yesterday I also realized our video stopped recording before we could upload it, so I fixed that today. We're back. So yesterday's video cut out before the end, unfortunately. And so we have the online gamer. Those who enter tech will quickly find. Hold up, this one looks like it's gonna be a banger. Let me make my camera smaller. Those who enter tech will quickly find that there isn't enough time in their day to absorb everything that seems necessary. This is true for most things in life. For a moment, take a step back from your industry and consider where you might best belong. Okay, online gamers spitting right now. Okay, let's consider time management as a conduit for joy. If life is something you are supposed to enjoy, then how you manage your time determines where you stake your joy. Yo! Okay, this is actually a crazy comment. Sometimes both the hunch you had and the risk you took didn't pay off. You received no joy. So you catch a new wind, set sail for a different course, and find something else. Time management is not concerned with the prettiest sail and how many times you can set a different course. Time management is about recognizing when that wind is for you. Oh my god! And never looking back. I gotta copy and paste this into the Discord later today. This is a crazy comment. Yeah, I think this is that was just wonderfully written. Yeah, I feel like half the people who write comments and some people who send me some messages, the way they write is just infectious. Like, it is just incredible. Like, this is actual, like, I would hope that through, maybe in another multiverse, years of toil, spinning that web and writing intensely, I would be able to write something like this. But probably unlikely. Like, this is incredible. Especially the time and the risk you took didn't pay off. And then the EM dash here, you received no joy. That was incredible. Yeah, that's just fire. That is just fire. And I agree with all of it. I think let's consider time management as a conduit for joy is just super, super fire. And yeah, it begs a lot of questions. I think especially with the learning journey, I always think back, exactly how, what direction is my compass pointing? Where am I going? Is this where I should be going? And I think there's this kind of confusing aspect about just trying to do something, you want to do. There's always a lot of, I feel like there's always a lot of pressure on like finding your passion and doing this and doing that. But I feel like one of the things that really helped me was, I think someone implored me to ask, instead of asking what my passion was, they implored me to ask, what did I have to offer? And unfortunately, the answer was not something that I liked, but the answer is programming. I was already here. I already have the skills, and it is something I do have to offer. And so a lot of the value that I can extract, at least in the short term, if we consider, everything in the long term, and then maybe as like a DFS, the shortest path to, I guess, the reward with the greatest portability was something programming related. And although that wasn't didn't really want to acknowledge or hear that at the time, I think it's definitely why this channel exists. And so, yeah, I just agree. It's just a fire, very, very fire comment. And time management is not concerned with the prettiest cell and how many times you can set a different course. It's just a legendary comment. But yeah, I also think sometimes there's just a fire comment. Just an absolutely fire comment. I'm gonna have to reflect on this one. Yeah, I should I also don't know if I say this, but I don't pre-read any of the comments before. Sometimes like if I randomly like between a session check my phone, I'll read the comments. But most of the time I don't pre-read the comments. So maybe I should, so I can have a better understanding. But yeah, I definitely it's just a legendary comment. Sometimes both true. Definitely true, man. So, Botea Public says, so what's your game plan? Just wondering, like any projects or just the daily LeetCode? The game plan, so this is actually, I don't know if I mentioned this in another video, but the LeetCode challenge, is like a side effect. It's not exactly the main thing. And I think the best way to put this, I don't know if anyone has seen Doctor Strange, but there's a part in the movie where, we have a surgeon, his hands are broken, right? And he basically goes to the sacred temple in the middle of nowhere to learn magic, and he just wants magic, right? So that he can move his hands again and return back to being a surgeon. It's basically the plot of the movie. In trying to find that place in the middle of nowhere, he finds a man who's playing basketball who used to be in a wheelchair. And so the man who can now walk around, who used to be in the wheelchair, tells him to go to this place in the middle of nowhere. He gets the magic. He becomes Doctor Strange. But I think there's a little bit of beauty in that small subsection right before he goes to the middle of nowhere, because you'd think, basically, the doctor, through all this time, Doctor Strange, he spends pretty much an hour and a half in the movie grinding to become, practicing all this magic on the top of Mount Everest, all these things, right? Just to be able to wield magic, and presumably his goal is to just go back to being a surgeon, but he doesn't. It seems like most of the students who go through there for a specific thing end up just being enamored by magic and staying. But I think one of the coolest parts of the Doctor Strange movie is actually the guy who directs him to the temple, because in the beginning you think he's just a guy, but at the end, after watching Doctor Strange do all of these things to basically get the ability to cast magic, you realize that the guy who's just playing basketball can do just as much magic as Doctor Strange. Instead, he used it to channel the magic through down his spine so that he can walk every day rather than, sitting in the sanctum and fighting evil goonies. And there's just something incredible about that, because it seems like him learning magic, although it was an incredible goal, an incredible thing to do, is just a side effect. What his main focus on was just living, what that magic allowed him to do, which was live his life. And so this all the way back around to LeetCode. The goal, the LeetCode, I wouldn't say is the main goal. LeetCode is just I'll use online gamers' words here. Actually, I probably can't, but LeetCode is just a vehicle to practice focus, basically. And I think there's a way that these problems are structured where there is a sort of, if we consider like the solution space, maybe we can consider creativity as an almost unbounded solution space, or that we can consider that an act can be creative when it has an unbounded solution space. And I think a lot of these problems in LeetCode are that way. And I think the issue that comes with creative problems is they're usually not binary. And LeetCode is one of those, or I think the domain of these kinds of puzzles, and I think most good literature, stories, games, puzzles have an aspect where, there's almost an unbounded set of like creative options, like when you're reading a story, reading a book, watching a movie, where you can see yourself, in you can place your own human story into, there's space in the story for you to get creative and place your own like human condition in the story. And LeetCode, chess, and all these things I think are like that, where there's so much unbounded availability for space, like of solutions, but also the answer is binary. Either it passes the test or it doesn't. And then I think that's just like a really, really effective vehicle for training focus, at least for myself. So I really use LeetCode every day as a way to like center myself and just focus for an hour. And then doing that, for some reason, I don't really know how this stuff works, but there seems to be a lot that we don't know. But for some reason, it makes it easier for me to focus on things outside of LeetCode. So yeah, I try to use it as like a tool to practice focus, and then outside of that, it just lets me focus on work easier. It lets me focus when I have conversations with people. It lets me focus and have patience when I'm trying to like do something else. And so that's basically the goal. But the goal, other goal there is just I'd like to finish the problems, all the LeetCode problems, and then maybe we just keep doing it. Because I don't really know what we do after. I got a question that maybe we could do Code Wars after, or the Euler project. But that would be pretty cool. But that would be the goal, and I'd like to do a lot of other things as well. I don't know if if you scroll down, if you click my channel and scroll down, there's some animations I used to make, and that's something I definitely would like to do in the future. I'm not a very good storyteller, so I'd like to be able to at least I guess the cool thing with animation is you get to just at least with traditional animation, you bring on a Sakuga animator and they're just animating one part of a already set together anime, and it's just a beautiful like symphony of motion. So I think the part with that would be cool, just being able to do something I can't tell a story, so I think being able to tell someone else's story or a piece of it through my lens, I think would be cool. But who knows? But yeah, that'd be cool. I also have another plan for some applications. So I think there's an application I haven't started yet, but I'm in the scaffolding stage, and I think it's gonna be a banger. But we'll see. We shall see. I'd like to have more information maybe by next week. Maybe my next week. But yeah, awesome comments, man. It's just some really thought-provoking stuff. I would also, I'm curious. Yeah, I would definitely like to see. Yeah, I read. It's just interesting. It is just interesting, especially the app. The app I tend to create, I plan to make. I think, hopefully, I'm trying to make something. I watched. There's a balance between. I watched a pretty cool video by some guy on YouTube, and I think he put into words some things I was thinking about, and I think I'm gonna try and make the application. It remains to be seen whether or not it will be worth anyone's time, but maybe we'll try and make it anyway, and then we'll see how it goes. But it's not a race to the bottom of the brainstem. So I'm not trying to get into the base of your cerebellum. Okay, this is going to be a very above board application. So I think it'll be pretty cool. And yeah, I have a few more planned, but I would like to start on them soon. But yeah, I'm still figuring out how to make this whole schedule thing work. And also, sorry, this is a really long intro today. I'm gonna have to restart the timer. I'm realizing that sleep might be I think maybe everyone knows already, but yeah, I struggle to stay on a regular and consistent sleep schedule. And so I think that definitely has a play. Because I'm definitely noticing, I think like I was saying before, since I'm doing more now, the margin of error is a little tighter. It can't be as high. So a slight error kind of throws the whole ship off. And then these minor inconveniences or like incongruencies and inconsistencies kind of have like a butterfly effect and kind of throw off the whole thing eventually. But I didn't realize that sleep was such a big part of it. One aspect I noticed is that when I'm lower on sleep or haven't been getting consistent sleep, I'm definitely more creative, but I can't focus. I didn't realize it, but the last few LeetCode sessions, I've just been unable to focus. For example, yesterday's problem on find all good indices, there's like a general cloudiness. I just couldn't focus or center my mind on the problem, which was kind of an issue because the reason, as we go back to the beginning, the reason I was doing the LeetCode is part of a vehicle for training focus. And while it still helped me yesterday anyway, I didn't get as many of the benefits as I usually do, which kind of was not flames. So I'm not really sure. I think the solution is just to sleep on time, but that's always easier said than done. I think I just need to pull the trigger on the hue light bulb situation, and we need to make that happen. Maybe I'll just get like 4 of them, and then I'll just point them directly on top of my corneas, and then at 9, they're just all going to turn on simultaneously, and then all will be well in the world. So yeah, I think we just need to do that. So bit of a blessing and a curse. So that is what we will try and do. And yeah, that is what we'll try and do. Yeah, and yeah, a lot of, I guess, yeah, it's just very interesting. A lot of ideas spinning. So that is a lot of talking. Apologies for the very, very long introduction. So we're just going to jump into the problems as usual. And yeah, so let us do it. I need to reset this timer. And we're going to jump into it. The HCC needs you. So you're going to want to join the hyperbolic coding chamber because it's a legendary coding chamber. We have hundreds of millions of people joining every single day. And the Discord is becoming so large that we're actually borrowing DNS records from other top tech companies to help redirect it to the Discord invite link. So to make sure all of those efforts don't go to waste, you're going to want to click the invite to the Discord before our temporary DNS records expire. And yeah, so you're going to want to do that. And we're going to jump into today. We're done with the weekly contest. We got to explore a lot of problems there, or a lot of potential solutions. So we're just going to move forward. We got 3 out of 4, and which is not the worst thing in the world. Looks like we did word pattern already. Or did we not actually? Oh yeah, I don't think we finished word pattern. So that's what we're gonna do. And so let's jump into it. So we have 1 hour. Def word pattern, comma S, mapping dog A, split S mapping. So let's reread this problem. Given a pattern and a string S, find if S follows the same pattern. Here, follow means a full match, such that there is a bijection between a letter in pattern and a non-empty word in S. I'm not sure what the word bijection means. Between a letter in pattern and a non-empty word in S. So we're given a pattern ABBA in S, which equals dog, cat, cat, and dog. Do they follow the same pattern? Yes. So we're given A, B, B, A, dog, cat, cat, fish. This doesn't match because A should map to dog and B should map to cat and fish should map to a new letter, but instead it maps to A. Just not playing. This pattern is A, and it's false because we have 2 different types basically. Pattern can be up to a length of 300. Pattern contains only lowercase English letters. S.length will be at least 1 word, or at least 1 character. I see. And S contains only lowercase English letters and spaces. S does not contain any leading or trailing spaces, which is important to note. All the words in S are separated by a single space. And so our way of solving this, we created a new hash. We split it. And we made an assumption that the pattern and S are parallel in the sense that pattern has individual characters and that in S, if we split all the words by space, we should get spaces plus 1 should equal pattern, or there should be enough words if we split by space such that they map to the number of characters in pattern. Then we iterate over the characters of pattern, and we check if the mapping, so if mapping.key, if we have a key for pattern, so pattern sub IDX, so if we have a key for A, if we don't have a key for A, and we don't have a key for the first word in S, then we set them. We set the A to map to dog, and dog to map to A. Okay, so let's say we do have a key for both of them. Oh, so we go to the next case. If the mapping of A does not map to the word, so if A doesn't map to dog, and dog doesn't map to A, then we return false, which seems like it makes sense, except the issue that we run into is that when our symbols, another assumption, it seems like the unknown assumption that we made was that pattern does not equal S. And we find in this case that it does, which breaks the mapping. And so what we want to do is pretty much translate a letter to a number instead, to pretty much mean a category. So A would map to 0, and B would map to 1, and C would map to 2. This one could get messy this way, so I'm gonna make this smaller so it's easier to read. And I'm gonna make my camera smaller because it's still big. ABC maps to BCA, and the issue that so I think what we need to do is we have A maps to B here, and B maps to A, which breaks our mapping. So I think this should work. Question is how to do that. What we could use another mapping or another hash, and this hash would simply map a letter to a category. And then once we have that, we would we'd be able to know that A maps to 0, and in our mapping, would we map B to 0 or A? I think we'd map it to 0. So then we'd also have to update the if statements to say if B sub, well, first we'd have to translate B to its category. So we translate B to its category, which should be 0, and then we translate A to its category, which would be 0. To check if they match. then yeah, that would replace this if else if here, because we're checking if A maps to dog here or A maps to B, and A is going to map to Z. Yeah, basically we need a proxy. I think everything is going to map through to, with the category, and instead, after mapping through with the category, we probably shouldn't be using the letter anymore. And so what we could say is if we don't have a mapping for the key, if we don't have a key for this category, and we don't have a key for this word, here is where we would use the category. So I think one reason why this code is so confusing is because my variables are very general. I'm using mapping, and we're really mapping here is two different things. We're mapping a category to, we'll just call it category to string. And it's going to be a two-way mapping, right? A is going to map to B, and B is going to map to A. But A and B are just general element names, not actual letters. If you call it category to string, for some reason you can't do. Oh, it is working. So we'll call this category to. And the other thing we'll change, instead of doing pattern sub pattern IDF, we're just gonna do pattern sub pattern index is equal to pattern letter. Then anywhere we see pattern sub IDX, or change it with pattern letter. Okay. And then we'll do word now. So anywhere we saw S sub split sub pattern index, we'll replace it with word. Yeah, this is already much easier, and it's an issue I seem to make very frequently. I'm not exactly certain why. So this is much easier to read. Now we have category to string. Now we just need pattern to category. And this is gonna map a pattern letter, right, to a category. And so to do that, I think we might want to do that actually beforehand, right? If we do it beforehand, then it might be simpler. So we can just have a counter which equals 0, and we're just going to do pattern. It's not an array. Actually, we can just do dot split empty string each do letter. And what we're going to do is say if pattern to category does not have a key, right, for this letter, we're going to say pattern to category, right, sub letter is going to equal the counter, and we're going to say pattern to category, so counter is going to be equal to letters. It's going to be a two-way mapping, and they'll do counter plus equal 1. Yeah, this, I don't think this problem is too difficult, but I think it definitely tests some like let's see what this looks like. Undefined local variable. I must have misspelled on line 27. So A maps to 0, 0 maps to A, B maps to 1, 1 maps to B, which is perfect. I think this is running a lot of test cases. What is going on? So I just run it with a simple test case. Okay, and instead of mapping A to dog, we want to update that, right? So instead of mapping pattern letter, you would have a category, right, which would just be pattern to category, right? We take a pattern letter, and if we have a category for this, this is from category to string. Oh, right. Then we would map it, instead of pattern letter, we want to use the category. And if we don't have, so if we don't have a key for this category, right, and we don't have a key for the word itself, right, then we're going to set it. So say category. So instead of pattern letter, we're going to use category. And then we're also going to map the string, or I should have said category to word. It would have been easier to read. And then we're going to say if category to, let's just update it so that we get in a good habit. I want to say it's category to word. Okay, this is so much easier to read now. We already spent 18 minutes on this problem. Category to word key. So if we don't have a word for this category, right, but also we don't have a category for this word, then we're going to set the category, right? We're going to map the category to the word and the word to the category. And then if we try and pull out the word that maps to this category and it doesn't equal the current word that we're at, then that would be an issue. Or if we pull out the word, right, and it doesn't map to the category, then that would be an issue. So I think this should still work, but it doesn't. Oh, I think we have an issue here. This should be category, word to category. So you map the category to the word and the word to the category. So this should still work, and they'll try the remaining test cases. And it does work. So then we'll try the test case that failed us. And so it works for that one, and let's see if it passes. Oh. So we break it up into 3 categories. We can't actually, because they're all mapped to 0. A maps to 0 and 0 maps to A. 0 maps to A and A maps to 0. Such that there's a bijection between a letter in pattern and a non-empty word in S. Pattern equals ABBA, S equals dog, cat, cat, dog. Dog, cat, cat, fish. Pattern equals quadruple A. Wait, so why did that fail? Well, I think another thing we can check, right, is if we split. Another thing we can check, and there's a lot of code here. But we know that if pattern to category, or we can really just do pattern.length does not equal S sub split dot length. Now, could that fail us if we had A, B, B, C? Right, we should still have 4 characters, and so they have to be parallel. That was an assumption that we made, that they're parallel. And it looks like we shouldn't have made that assumption, so let's return false in this case. And I think that should pass us for this case, because these are not parallel. Oh, so it does work. I thought our solution wasn't going to work in the end. I think if we remove the puts, it's still very slow. Oh, it's actually faster than 90% of Ruby solutions, but to be fair, there's usually not many Ruby solutions. Complicated. So yeah, so we're gonna jump into it. Let me see. So we got this one looking good. What's the time complexity? So we do P operations, or P dot length operations to get here. So we do P dot length. That would be P. And then we do S operations, which would be P plus S. And then iterate over P. So PP plus S. I would say it looks like it's P plus S with P plus S time. I mean P plus S and then P plus S space, where P is the number of letters in P in the pattern variable, and S is the number of spaces, I guess, in the string. Plus 1, because the space, we're using a hash, 2 hashes, but we're using a hash where the properties or the number of keys that we'll set will be equivalent to P plus S, because we're mapping them back to each other. Two hash maps. Most naive way to start thinking about this problem is to have a single hash map. Not in the mapping. If you see a character which is already one of the keys mapping. It's getting into the end. This cyber check will work for cases such as ABBA. It will fail for character word. Fix for this is to have 2 hash maps, one for mapping characters to words and the other for mapping words to characters. Word pair, if the character is not that word is already in the word to character. That word is already in the word. Then you can return false immediately, since it has been mapped with some other character before. Is in the character to word mapping. You just need to check whether the current word is in the character to word mapping. You just need to check whether the current word matches with the word which met in the word. So if the car map contains the letter, or if it doesn't contain it, and if the map word contains W, return false. Why do they have to do that catch? If the map underscore word dot contains W. So if we don't have a map, if we don't have a key for the character, and if we have a key for the word already. Oh, I see. Because they're not doing the double mapping like we are. They're mapping C to W and W to C, but in 2 different maps. So if the word already exists in the word map, then it means it's already mapped to another character. Else, map word equals map car dot get C. If map word does not equal the word that C mapped to, then they return false. C. They made a good point here. The character in the word hash map has a complexity. Oh no, the character hash map has a complexity of 01, because there can only be 26 keys, because the constraints mention that there can only be lowercase English letters. Addendum: rather than keeping 2 hash maps, we can only keep character to word mapping. we can only keep character to word mapping whenever we find a character that is not in the mapping. Check whether the word in the current this is trading time off for better space. I don't know. Yeah, okay, so interesting. You are playing the following nim game with your friend. Initially, there is a heap of stones on the table. You and your friend will alternate taking turns. Heap of stones on the table. You and your friend will alternate taking turns, and you go first. On each turn, the person whose turn it is. Initially, there's a heap of stones on the table. You and your friend will alternate taking turns, and you go first. On each turn, the person whose turn it is will remove 1 to 3 stones from the heap. When one who removes the last stone is the winner. Given n, the number of stones in the heap, return true if you can win the game, assuming both you and your friend play optimally, otherwise return false. Looks like a tree problem. It looks like this has a lot of dislikes. This gives me tree vibes. This gives me a tree vibe. I wish I had the iPad near me so I could draw this out. We could say that there's a heap of stones on the table, right? And we could visualize this as the top of the tree being, let's just say, actually, let me read the example to make sure I understand it. Given n, the number of stones in the heap, return true if you can win the game, assuming both you and your friend play optimally, otherwise return false. Input n equals 4, output equals false. Explanation, there are the possible outcomes. You remove 1 stone, your friend removes 3 stones, including the last stone, your friend wins. You remove 2 stones, and your friend removes 2 stones. Including the last one, your friend wins. You remove 3 stones, your friend removes the last stone, your friend wins. I see, yeah. N equals 1 because you can take the first stone and win. But, yeah, how do you win here? If I go first, then I remove a stone. My friend goes after it. They always remove the stone. Oh, I can take 2 stones and win. I see. Okay, so I think we could represent this as a tree. And if we represent this as a tree, every other level in the tree will be my turn. So if we start at 4, right, I can either take the stone at the top plus 1. I mean, I can either take 1 stone, 2 stone, or 3 stones. So I can take 1. That would leave me at 3. I can take another one. It's actually not it's an n-ary tree or a tertiary tree. Take 2 stones and end up at 2, or we'll just do it like this. Do it like this, or I can take 3 stones and end up at 1. Okay. This would be really, really bad time complexity wise. And n can be up to 2 to the 31, so I don't think this is going to work. Even though it could be phrased as a path problem. Does a path exist to the string? But we'll do it this way anyway. So we'll start at 4. This will be our turn. Assuming our friend takes a turn, what nodes would spawn after it? I guess every other level would be our turn, starting from the first. Every other level. So I think we probably could do this with the BFS. We'll mark the nodes based on whose turn it is. And that's how we'll know if we win or not, or if it's possible for us to win. We're visiting every possible node in the graph, I believe. But we can just toggle the choices, I think, right? Because if I create a node here of 4, to be a child of 4, all of these potential nodes will be my friend's turn. Then all of the options that result from this will be my turn. And then I think that could work. So we'll try a BFS-based approach. And since there's no native deck implementation in Ruby, time complexity is probably going to be abysmal. So we can do this one in TypeScript, even though there's no native one in this one either. But we'll do it anyway and see how it goes. So basically we want to do BFS every other level is my turn. And we'll mark nodes. We'll mark nodes with turn. Or maybe we don't have to mark nodes with turn. Instead of that, would be a lot of extra data. We could just keep track of the level that we're on. And if it's an odd level, it would be my turn. Or odd levels on my turn. This is definitely, I'm sure there's a math-based solution to this. But we'll do Q equals N, right? And the turn 0 will count for my turn, and 1 will count for the friend's turn. I forgot this is JavaScript. And we don't get any type annotations, so I don't know if there's any point in using the types right now. And then we'll just say while q dot length is not equal 0, we're going to want to do some work. the end will return false, and we'll take a node, which we'll take off the front, and then we'll destructure the array for node and turn. 0 equals my turn, and then we want to visit our neighbors starting at 1. I is less than or equal to 3. I plus plus. But I think what we basically want to check, the way we'll know if we won is if the node minus 1, 2, or 3. I think it's just actually minus 3, because if we can choose any of 1, 2, or 3, we'll just always assume we'll take our lowest, our largest amount, and we'll say, or we'll just call our turn 1 then. It might be easier to simplify the code. So if turn and node minus 3 is less than or equal to 0, and we'll return true so we can win. Otherwise, we want to visit the next nodes in the level, and what we're going to do is say q.push node minus I, and the turn is going to be not turn. I don't know if you can actually do this, so we'll just say toggle, and it's going to take a num, which is a number, and return a number. And if num equals 1, it returns 0, and if it equals 0, it returns 1. And we'll just call toggle. I don't know if you can not add. We don't have much time to check, so we'll just say toggle turn. So this line is so we don't run forever. So if node minus I is greater than 0, it means we still have a chance to win. If it's less than or equal to 0, it means we already lost. There's no point in considering it. So if we try with 4, it's gonna be our turn. We're not gonna be able to win, but we're gonna push on to the Q, 3, 2, and 1. And then it's gonna be our friend's turn, right? It's not our turn, so we're not gonna return true. And then we're gonna say, okay, Well, 3 is 3 minus 1. Oh, if they also play optimally. Whoa. If my friend is also playing optimally. Oh, yeah. No, wait. If I can win. I think I understand the problem now. We're basically searching for the shortest path to 0, and I think it's a bipartite. I don't know if this is the right name, but there's a type of graph, or it's called node coloring. Basically, coloring the nodes based off of a property. We want to find the shortest node, the shortest path to the 0, and we want to know if the node at the end was my turn or my friend's turn, because they would also be playing. They would also be playing optimally. So if that's the case, then we'll remove this one. And what we'll say is, if the node minus 3 is less than or equal to 0, then we're done. And the question is, which one we return is going to be, if it's turn, we're going to return true that we could win. Otherwise, we're going to return false because it means that it was my friend's turn and they won. So if we start at 4, I go first. The nodes that we get are 3, 2, and 1. It's my friend's turn. So now we go to 3, right? I always say if node minus 3 is less than or equal to 0, well, it is, so you'd return false because it would be my friend's turn and they won. My only issue with this test case is that 4 works because taking 3 was the optimal move here. But I think either way, BFS usually, the nature of BFS, since we always visit the last there's a property of BFS that usually lends well to shortest path. So yeah, even for 4, it takes a long time. TLE. Oh, we got the wrong answer. For 5, we return false. So they got to 5. I think node minus 3 might be prematurely returning us. I think what we need to do is say if node is less than or equal to 0. That way I think we should still pass the test cases. Now we get true, false, 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 and true, true. shortest path. I think I'm remembering something Thomas said. I think we can just search from the target. If we started at 5 and then tried to see how fast we could get to... If we started at 0 and saw how fast we could get to 5, first person to get to 5 wins. This is simpler because there's less paths. The shortest path to 5 is easier to find. We start at 0. So we still get the same output. Why is that? I wish we had the iPad so we could draw it out. Something about these shortest path problems. I'm going to read the ADM after this. Something about them both playing optimally is messing me up. Shortest path. We have the tree. We're starting. This is just like climbing stairs. It's just like snakes and ladders. It's just like climbing stairs, snakes and ladder. It's just like coin change. All these problems have a similar property, or I always see them as shortest path, and I implement them, and then I run into a roadblock. The fact is, they're both playing optimally. I think where the problem is, we're stopping early, which doesn't mean we found the shortest path. My algorithms usually find the shortest path by visiting all paths, which is why they're usually TLE. What if instead we start from 5 and we check all the paths that go to 0. Check all the paths that go to 0. We check all the paths that go to 0. Yeah, I don't know why. I think I see why there's so many dislikes. This is like I think this is probably a medium just because it looks like coin change. The solution is probably really simple. if we start at 5 instead? We're stopping too early. Problem is, these other problems, climbing stairs, I think it just asks if you can get to a specific stair. Coin change is asking if it's even possible to create a specific denomination given a set of coins. Those problems are just checking if something's possible. This time we're asking for the optimal solution, which means we can't stop as soon as we find the node. We would need to keep track of which node. We'll call shortest. What if we kept track of shortest path with something like math dot, or I know, I think it's just infinity. Something like infinity. That way we could say that way if node is greater than or equal to n, it would mean that it's a potential way to win. We also need to know how long the path was. Do node, and this is going to be pretty bad. We'll do node turn and path. And path is less than shortest path. So if someone gets to the shortest path first and their values are the same, we're not going to update it. And we're just going to always assume that our friend wins. And we say if winning turn equals 1, return true. Actually, we just have to say if winning turn equals 1. And path is less than shortest path. We'll say is winning turn equals turn. Shortest path equals path. Oh wait, why is my it's gonna be TLE. This is never ending. If node is already greater than or equal to n, we'll just say if it's less than or equal to n, then we'll do it. Because if we add to it, we're already going to go over it. Still wrong on 5. preceding term would equal term. He gets to 5 first. Update it. And it was my turn. That is unfortunate. I'm sure there's a math way to do this and something about odd and even, so we'll think about that tomorrow. But something about shortest path problems, I'm going to read the ADM in preparation for this tomorrow, and I think we should be able to solve it.